Welcome to Ask and Learn.
In this question, we need to calculate the area which is enclosed between these two curves given as the function y equals to x square plus 1 and y equals to x plus 1. These are the two given equations. So, in the first part, we need to calculate the area of the region enclosed between these by partitioning the x-axis, and in second part, we need to calculate the same area by partitioning the y-axis. So first of all, we will plot the graph of these two equations. So we plotted the graphs of these two equations. This purple straight line is the graph for y equals to x plus 1, and this black curve is for y equals to x square plus 1. And we also shaded the region which is enclosed between these two curves. And now first of all, we will find out the points of intersection for these two curves, and we can calculate the points of intersection by equating these two expressions, x square plus 1 equal to x plus 1. So we will get here x square plus 1 equals to x plus 1, and by simplifying this, we will get here as x square minus x equals to 0, and by factorizing this, we will get x times x minus 1 equals to 0, and from here we will get either x equals to 0 or x equals to 1. And we can calculate y also for these two values of x. So for x equals to 0, y will be 1 by substituting it in any of these equations. So we will get it y equals to 1, and for x equals to 1, we will get y equals to 1 plus 1, which is 2. So we got the points of intersection for these two curves. The first point of intersection is 0 comma 1, which is this one. So this point is 0 comma 1, and here this point is 1 comma 2. So this one will be 1 comma 2. So we got the points of intersection. We can use these points for finding the limits for the integral. And now in the first part, we will calculate the area of this region by partitioning the x-axis. So in the first part, we will get this area A by integrating for the limit for x equals to 0 to x equals to 1. So this will be x equals to 0 to for the 1. We can see this area is extending from x equals to 0 to 1. Now this will be for f of x minus g of x, and f of x will be the upper curve, which is y equals to x plus 1. So this will be x plus 1 minus g of x, which is the lower curve, which is y equals to x square plus 1. So minus x square plus 1 dot dx. So this will give the area enclosed by these two curves. Now we will integrate this expression, and we will get this area A equals to the integral for first of all, we will simplify this. By simplifying this, we will get a simpler expression, and we will get here integral for 0 to 1, and this will be x minus x square, as here plus 1 and again minus 1 will be cancelled. So this will be x minus x square dot dx. Now we can integrate it easily, and this will be area A equals to the integral of x will be x square over 2, and the integral of x square will be x cube over 3 for the limit 0 to 1. And in this we will get area equals to for the upper limit, this will be 1 over 2 minus 1 over 3, and for the lower limit these both will be 0, so we will neglect these, and here the area will become 1 over 6 square units. So we got the area of the region which is enclosed between these two curves by partitioning the x-axis. Now for the second part, we will calculate the same area by partitioning the y-axis. So first of all, we will look at the figure for the lower and upper curve. So here is the figure, and when we will partition the y-axis, we will see that the upper curve will be here this black one, which is y equals to x square plus 1, and from here we will get x equals to y minus 1 square root of y minus 1. So we can write here as the equation for this curve will be x equals to square root of y minus 1, and here we can see that the equation will be x equals to y minus 1. So we can write that equation here, x equals to y minus 1. So we got the equation for these two curves in terms of y. Now we can see the upper curve is this square root y minus 1, and the lower curve will be this x equals to y minus 1. So now we will use, and the limit will be from y equals to 1 to 2. Here we can see easily this area, this region is extending from y equals to 1 to 2. Now we will calculate the area by the expression, which is area will be, for the b part, by partitioning the y-axis, we will get the area as the integral for the limit. Here this will be 1 to 2, and this will be for f of y minus g of y. F of y will be the upper curve, which was square root y minus 1, and the g of y will be the lower curve, which was the straight line, as that was x equals to y minus 1. So minus y minus 1 dot dx. We can write this same expression in simplified form as area will be equal to integral for the limit 1 to 2, and this will become square root y minus 1 minus y plus 1. Sorry, this was not dx, but this was dy. By mistake I wrote here dx. This will be dy, and this will be again here dy. Now we will integrate this expression with respect to y, and we will get area A equals to the integral of square root y minus 1 will be y minus 1 to the power 3 by 2 over 3 by 2, and we can write that as 2 by 3 times y minus 1 to the power 3 by 2, and y will be integrated to y square over 2, 1 will be integrated to y, so this will be plus y for the limit 1 to 2. Now we will execute this limit, and we will get area A equals to, for the upper limit, this will become 2 by 3 times, here this will be 2 minus 1, which will be 1 to the power 3 by 2, and this will become 2 by 3 only, minus y square over 2, which will be 2 square over 2, which is 4 over 2, and that will be minus 2 only, plus y, this will become plus 2. This will be for the upper limit, and for lower limit this will become minus 2 by 3 times 1 minus 1, that will be 0 to the power 3 by 2, and that will become 0 only, minus 1 square over 2, that will be only 1 over 2, plus 1. Now by calculating this, we will get here the area equals to, this area will be equal to only 2 by 3 will remain in this bracket, minus 2 plus 2 will be 0, and minus, here this will become 1 minus 1 by 2, that will be 1 by 2 only, and by calculating this we will get here area A equals to 2 by 3 minus 1 by 2, this will produce here that will be 1 over 6 only, so 1 over 6 square units. So we got the area here by partitioning the y-axis in this second part, and we see that the area is same in both the parts, either by in the first part by partitioning x-axis, and in second part by partitioning the y-axis. I hope all of you got this question. Thank you.